Okay, question 7. What we have is parallel lines are indicated by the arrows. What I have to do is I have to figure out what x and y are, okay? So what I suggest for question 7 is that there's a rule, okay? What I ask you to remember is what's called the x factor, okay? What I mean by that is that z stands for alternate angles. This angle will equal that angle there. The x stands for vertically opposite angles, so that angle equals that one. This green one here will equal that one there. And the f stands for corresponding angles, which means this one here equals this one here, provided that these lines are parallel. Okay? For the most part, that's what you're going to use. Okay? So what I'd like you guys to zone in on is if we were to just take this part here. I'm just going to redraw this diagram because it's a bit full. So if I drew it like this and I said that's y and this one here is 115, what angle corresponds to that one there? 115 up there, and that makes y worth what? 65, because we're in a straight angle together. You have to add up to 180, so y is 65. A second person could have come along and done it this way. Another person might have said something like this. He might have said that's 115. They might have said that's 65. And they might have said that corresponds with that one to make it 65. There's more than one way of thinking of it. Okay?
Would you say the 115 will correspond with the angles below the y?
That one there?
Yeah.
That would be alternate. That 115 would be like a z. So you said that one and that one.
Yeah. They're
alternate. It's like you got the z and you just you redrew a z slightly differently, something like that.
So would that work?
Yeah, you have to say alternate though. They're alternate to each other, and that'd be 115, and then that'd be a straight angle with that one to give it the 65. Different way of doing it. Okay, several ways of doing it. Okay. Now, when we go back to our diagram, what we're looking at next is we found out that that's 65. Okay. Now we're going to use vertically opposite angles. Okay, so this one equals this one here. So what's this one, Dennis? What number? 50. Okay, and this one here? 65, because it has to add up to 180. And then finally, the angle x is going to be 180, take away 65, take away 50, and what do you get? Pretty sure you get 65 as well. Is that right? Yeah. What type of triangle would that be then? It's an isosceles triangle because two of the angles are the same size. Okay, so that's question 7 done. We'll now have a quick look at question 8. Okay, that's 8 there. Now, with question 8, you can see that this side here corresponds to that one there. Would you agree with that? I'm using the F. Okay, so I'm going to say that R is 50. Okay, what can I say about this part here? The Z, which means it's alternate. So Q is alternate to R, which means Q also equals 50. And it's also vertically opposite the other 50, if you want a different way of saying it. Then we have 50, 70, that will make a 60, because 50 plus 70 plus 60 is 180. And finally the S, anyway the S is corresponding to the 70, which makes the S worth 70. Or you could say 60 plus 50 is 110. 110 take away from 180 is 70. Several ways of doing it. Okay, question 9, the last one. Question 9. Okay, question 9 is here. We're looking for P. Ooh, this one is really to be difficult. Can anybody tell me, is there any other ones the same size as that one there? Where is it? Down here, 140. Okay? I can call that 40. Why can I call that 40? 180, yeah. I can call this 50. Yeah. Makes that 90 degrees. Makes the other one on top 90 degrees because it has to add up to 180. And that is vertically opposite to the P, which makes P 90 degrees.
But the angle just in front of the 140 be 140 as well. If it's the same.
This one here?
No, it's
Here?
no.
Here?
Left.
Here?
No, up. Left.
That?
There.
That's also 140.
Yeah.
And you could call that in turn, you could say that's 40. And then you could say that one there is 130, 50, and then work the 50 in that way as well. In two ways of doing it. Okay. Question 13. So that's 7, 8, 9, 13 so far. Okay guys, can anyone in the class tell me what do these two signals here mean? Means they're the same length, which means that the triangle PQR is isosceles, okay, which means that two angles have to be the same size. This means that this angle here is the same size as this angle here. So 180 minus 48 is 132, yeah? And 132 is divided equally amongst two different angles. So divide that by 2 and what you get? 66. So 2x equals 132, x equals 66. So each one of them is worth 66 each. Okay. We then go across here and we use the straight angle. So what do we know about the straight angle then? So it makes the other one 132. Once again, this is also a isosceles triangle because it says this length is the same as this one, which in turn means this angle is the same size as that one there. So 180 minus 132, 58, yeah, divided by 2. So 58 divided by 2.
48.
Oh, sorry, 48 divided by 2. 24, so that. So 24 and 24. Asking for the angle PQR. What's PQR? P to Q to R is 66. This corner here. And it says give me a reason in each case. I explained it. It's an isosceles triangle. Your two angles have to make it add up to 180. That's why it's 66. PSR. P to S to R, once again, it's an isosceles triangle. The obtuse angle is 132. Your two angles have to make it add to 180. Therefore, this angle's got to be 24. Okay. 19, yeah? We had the 19 was the last one you want me to do. Okay. So in the diagram, PQ equals QR. So that automatically makes it what? An isosceles triangle. And we know that that's 90 degrees, so what does that make the other two? 45 each, because 45 plus 45 plus 90 will turn it into 180. Okay, what do we know about the other angles? It's an equilateral triangle, so it's 60 all around. So we have 60 here, 60 here, and 60 here. What is the angle QPR? Q to P to R. 45. Isosceles triangle with a right angle in it, it's got to be 45 degrees. PSR? 60 degrees. Equilateral triangle's got to be 60. And QPS? 105 because it's the 45 plus the 60 to get me 105 degrees. Okay.